Hello, welcome to today's lesson. This is from section 4.4 if you are in period 3, 8, or 6. If you are in period 4, this is from section 4 in your 6.4 in your textbook. So this is a topic that I usually teach during this section, and it's usually included on the quiz for this section. But for this year, I felt like we already had enough problems, enough types of problems, and I decided to save this for after the quiz. And this will not be on a quiz anytime in the near future. It comes back again later on in the next chapter, but for now, it's just a lesson to take some notes on and try your best to understand as we go. So we are going to be solving for theta, but we're going to be doing this using a calculator. Okay, so these are not going to be special angles. Usually we'd find the reference angle and the quadrants and then get our answer. But these are going to be non-special angles. So we're going to need a calculator, and that's indicated by asking you to round to 2 decimal places. We're going to give answers in degrees such that theta is between 0 and 360. We could totally do this in radians, but we're just going to do it in degrees just to learn the concepts. So example 1, sine of theta equals this. That's a ratio. We're trying to find the angle. Okay, so we want to find the angle. We're given the ratio. Remember, ratios don't have units. So this is neither degrees nor radians. This angle could be degrees, could be radians. We want to find it in degrees. So to solve for theta, that's where we use the inverse button on the calculator. So that's the only time we use the inverse button is when we're looking for the angle. So what we're going to do is we're going to put degree mode. And again, the ratio has no units. Theta itself could be degrees or radians. We're picking degree mode because the direction said to give the answer in degrees. And what we're going to do is do sine inverse of 0.2347. And we get 13.57 degrees. Okay. That right there is an answer. The calculator is always going to give you a good answer here. And I could check that answer. Let me adjust my lighting, see if I can do that. Yeah, that looks good. Okay. So I can check that answer by doing regular sine and putting the angle in. If I put the angle in, I'm going to get the ratio. It's not exact because this is a decimal approximation, but it's pretty close to the given ratio. So I feel confident with that answer. Now, we're supposed to give 2 answers. That's just our first answer. So similar to what we do with our non-calculator problems, we want to figure out the other quadrant in which theta may lie. So we know that sine is positive. So that means our answers could be in quadrants 1 or 2. This is the answer in quadrant 1. The calculator gave us the answer in quadrant 1. What we need to do is go to quadrant 2 and find the angle that has the same reference angle as that. Now, since this is an acute angle and it's positive, that is the reference angle. All right, so that's also theta prime, because if I were to sketch 13.57, the acute angle between the terminal side and the x-axis is 13.57. So not only is this an answer for the problem, but this is also our reference angle. So when we go over here to quadrant 2, we're going to fall short of 180 by that much. This is a calculator problem. There's no need to do any of that mathematics using mental math, not even on paper. I'm just going to go ahead and use the calculator and get 166.43 as my other answer, rounding to 2 places because the direction said so. And if you want to check that answer, hit sine, regular sine, not inverse. Put that angle in, and the ratio you should get out should be very, very close to the given ratio of 0.2347. So those are our 2 answers, between 0 and 360, such that sine of this angle gives that ratio, and sine of this angle gives that ratio. Not so bad. It gets a little weird in the next few examples. Let's move on to number 2. Okay, for number 2, the given problem is that tangent is equal to negative 0.6822. So we start this problem the same as last time. We're trying to find the angle, so we're going to use tan inverse. We're going to put the ratio in. The ratio has no units. Theta could be degrees or radians. We're going to stay in degree mode because the direction said to give answers in degrees. Okay, so tan inverse of negative 0.6822. This is an answer for theta. Okay, rounding to 2 places, you could go 0.30 or just 0.3, whatever you prefer. And that is a correct answer for theta, but I can't circle it. I told you it's going to get a little weird. If you recall, in the directions, it said that your answers had to be between 0 and 360. That's not between 0 and 360 because it's negative. So that is an answer. The calculator didn't lie to us. If I do tangent of negative 34.30, I'm going to get pretty close to this ratio. All right, so it is a correct answer, but it's not within the restrictions. So what we have to do is we have to use that information to find our answers. Let's figure out what quadrants our answers should be in. The given problem, we're told that tangent is negative. So that means we're looking for an answer in quadrant 2 and an answer in quadrant 4. If I were to sketch this, it would be quadrant 4. Let's sketch that over here. But I'm not allowed to use it because it's negative, and the directions say we have to stay between 0 and 360. We're not allowed to use negatives. So what we need to do is we need to use this angle to find the reference angle and put it in the appropriate quadrants. So if this angle is negative 34.30, what's the reference angle? Well, the reference angle is going to be just the positive of that, because we want the positive acute angle between the terminal side and the x-axis, and that is positive 34.30. So that's our reference angle. What I want to do now is take that reference angle and put it in quadrant 2. So the angle in quadrant 2 that has a 34.30 reference angle is going to be 180 minus 34.3. Putting that in my calculator gives me 145.7. That I can use as an answer. Okay, it's between 0 and 360. The fact that it has the same reference angle as this is going to give me the 0.6822. And because I'm in quadrant 2 for this, tangent will be negative. And we can check that by doing the tangent of 147.7. Sure enough, we get that 0.6822. What did I do? Oh, I wrote it wrong. Sorry about that. When I subtracted, I should have had 145.7. Let me try that again. So 145.7 gets you really close to that negative 0.6822. Okay? So that's the answer in quadrant 2. Now we need the answer in quadrant 4. So I'm looking for this angle such that the reference angle is 34.30. Because if the reference angle is 34.30, then I'm going to get this number. I'm going to get the 6.6822. Okay? So I'm going to do 360 minus 34.3. I'm going to write the correct answer this time. There we go. And that is a correct answer. Because it has the same reference angle as this one, I'm going to get the 0.6822. Because this is in quadrant 4, tangent's going to be negative like it's supposed to be. So if I check that answer, tangent of 325.7 gives me the ratio I'm looking for. Okay? Challenge question for you. What would I get if I put tangent of the reference angle into the calculator? So not negative 34.3, but the reference angle itself. We get positive 0.6822. All right. Why are we getting the same number? Because angles that have the same reference angle are going to have the same ratio, technically the same absolute value. Okay. They're going to have the same numbers. What affects the SIGN is the quadrant. And if we were to sketch regular 34.30, that would be quadrant 1 where everybody's positive. So the fact that this angle, this angle, this angle, and this angle all have the same reference angle means when you do tangent, you're going to get the 0.6822. To get a negative, you have to make sure you're in quadrant 2 or 4. This is quadrant 2 with the appropriate reference angle. This is quadrant 4 with the appropriate reference angle. That's why those are our answers. All right. And just to recap, the reason we can't use this one, even though that's quadrant 4 and it gives us the right answer, we had to play the game because the direction said we had to go between 0 and 360. All right. I told you it gets kind of weird. All right. Are you glad I saved this for after the quiz? Probably. All right, here's number 3. This will be our last one on this topic. I have secant theta equals negative 3.251. To solve for theta, we would want to do secant inverse. But if you recall from our work in the previous section, we don't have a secant inverse button. So what we have to do, question mark, exclamation point. All right. So what we have to do is we have to rewrite secant as cosine. Okay. So if secant is this ratio, then cosine is 1 over that ratio. And we do have a cosine inverse button. Okay, so that's what we're going to put in our calculator. Cosine inverse 1 over negative 3.251. I get 107.91 degrees. That is a good answer. The calculator always gives you a good answer. Is that answer within the restrictions? Is it between 0 and 360? Yes. Then circle it up. It's a good answer. You can use it. Okay? Now, we're supposed to give 2 answers. So let's find out where the other answer lives. Since we know that secant is negative or cosine is negative, our answers are going to be in quadrant 2 and 3. This answer, if we sketch it, is quadrant 2. So we're looking now for the angle in quadrant 3 that has the same reference angle as this. Why can't I use this itself as a reference angle? How come 107.91 is not the reference angle? Because in the last example it was. Look, in the first example, the angle we got was the reference angle. In the second example, the angle we got, we just took the absolute value. This cannot be the reference angle. Why not? Because it's obtuse. So what we need to do is we need to find the reference angle. So this is a weird topic because it is the same process every time. Use the calculator, find the quadrants, use the reference angle. It's the same process every time, but sometimes the calculator gives us the reference angle. Sometimes it gives us a negative that we just make positive to get the reference angle. And sometimes the calculator gives us an obtuse angle. And to find the reference angle, we have to draw that angle or visualize it at the least. And the reference angle we're looking for is 180 minus 107.91. And the reference angle is 72.09. Okay, so that's the reference angle. So now we can find the angle in quadrant 3. It's 180 plus that. You probably do that in your head. You could probably do it in your head, but I messed it up on the calculator. All right, plus 252.09, and that's a correct answer. So now we have the answer that lives in quadrant 2. We have the answer that lives in quadrant 3. These have the same reference angle, so you're going to get the correct ratio. Because this is quadrant 2, secant will be negative. Because this is in quadrant 3, secant will be negative. So last bonus question here. What would I get if I found the secant of that? What is the secant of 72.09 without touching your calculator? The secant of 72.09 would be the positive of that. I don't have a secant button, so I have to do 1 over cosine real quick. But you're going to get the positive of that. Okay? The reason you're going to get the positive of that is because if you sketch 72.09 on its own, it's quadrant 1. So because that would be quadrant 1, secant would be positive. All right? So why do these 3 give you the same number? Why does this, and this all give you the 3.251? What do they have in common? They all have the same reference angle. What determines if you're going to get that negative that you want is if you're in quadrant 2 like this one or quadrant 3 like this one. All right? So that's the lesson. Usually we do a few more and have some for homework, but we're probably going to go ahead and move on in the next lesson. And again, kind of a weird topic because sometimes the calculator gives you an obtuse angle. Sometimes the calculator gives you a negative angle that you're not allowed to use as an answer. And then sometimes the calculator just gives you an acute angle like you would want. In a future section, in section 4.7, we will find out why the calculator gives us these different answers in these different scenarios, but we don't have enough information for me to explain that to you today. So be prepared. Someday in the future, very randomly, I'm going to say, that's why the calculator gave you all different types of answers. Thanks for watching, guys.